Here we want to solve the Caputo fractional derivative of order alpha equal to 12 over 2 for f of x equal to x raised to power 4. In our previous video, we solved for the same problem, but it was f of x equal to x cubed. But in this case, we want to see how we can solve for f of x equal to x raised to power 4. So now let's look at this problem carefully and let's see how we can solve it. Now we already know that our alpha is given to be 3 all over 2. Our n in this case is given to be 2. So all we need to do is just simply to substitute back into our formula. So anywhere we see alpha, all we need to do is just to simplify, also rather substitute and put our 3 all over 2. Our f of x in this case is given to be x raised to power 4. That is the value of our f of x. And then 1 all over gamma of n minus alpha. Our n is 2, our alpha is 3 all over 2. 2 minus 3 all over 2 definitely will give us gamma of 1 all over 2, which is still the same thing as the square root of pi. Now into our integral from 0 to x, here is going to be f of f double prime of in this case tau. So all over x minus tau. Our alpha is going to be 3 all over 2 minus n is 2, then plus 1. Now we have writing the same thing. X raised to power 4 is equal to 1 all over gamma of half is equal to the square root of pi. We have done this over and over again. So we have our 0 to x of f double prime of tau. Now remember we have f of x to be equal to, our f of x is equal to x raised to power 4. So f prime of x will now be 4x raised to power 3. F double prime of x, that's differentiating it the second time, will now give us 4 times 3, which will now be 12x squared. 12x squared. So in place of f double prime of tau, we are going to replace it with 12. Let's do in form of tau squared all over open bracket x minus tau. Now 3 all over 2 minus 2 plus 1 will still give us raised to power 1 all over 2. Okay, now let's go to the next step. We have the same thing, 3 all over 2 x raised to power 4 is equal to, we have 12 all over the square root of pi into our integral 0 to x. We have tau square all over, okay, here we have the tau square all over x minus tau. Okay, let's say this raised to power 1 all over 2, the tau. Now using the standard integral formula. Now when using the standard integral formula, here's what we have. Let's say this right here now is the standard integral formula. Tau raised to power m all over x raised to x minus tau raised to power n the tau. Now this is still the same thing as, this is gamma rather. So we have gamma of what, n plus 1, close the bracket, gamma of 1 minus n all over gamma of m plus 2 minus m. Then x raised to power m plus 1 minus m. Okay, that's what we have. So all we need to do is just to substitute. Now our m is given to be 2. We know in this case our m is given to be 2. Let's show you. So that's what we have here. Our m, the power of our m is 2. The power of tau here is 2, which is our m. So now let's continue. Our m is equal to 2. Our n in this case is 1 all over 2. That's from the value of our m here, which corresponds to this, is equal to 1 all over 2. So that is how we got the value of our m. So now applying the same formula, if we decide to apply the same formula, remember what we're doing is just simply to solve the integral. Then we have tau squared all over x minus tau raised to power 1 all over 2. The tau is given to the gamma of what again? M plus 1, and our m is 2. 2 plus 1 will now give us 3. So we have gamma of 3, then gamma of 1 minus m, which will now give us 1 all over 2 over gamma of 7 all over 2. 7 all over 2. Then x raised to power what? M plus 1 minus m. So we have our x raised to power 5 all over 2. So all we need to do is just to simply simplify this gamma function. And gamma of 3, what is the value of gamma of 3? Gamma of 3 is 2 factorial, which is still the same thing as 2 times the square root of pi. Now gamma of half is always given to be the square root of pi all over gamma of 7 all over 2. If you solve it, we're going to get 15 all over 8 into the square root of pi. Now this will now simplify to 16 all over 15. So what that means is that our integral is now equal to 16 all over 15 x raised to power 5 all over 2. So we got x raised to power 5 all over 2. That is the value of our integral. Now if we decide to take it back and substitute into our general question, so we have this is equal to, now remember we have 12 all over the square root of pi multiplied by 16 all over 15 x raised to power 5 all over 2. Now if we multiply 12 multiplied by 16, I think it will give us 192, I think, all over 15 into the square root of pi. Then our x raised to power 5 all over 2, which if we simplify further, I think 3 can go into this, so we get 64 all over 5 into the square root of pi x raised to power 5 all over 2. Thank you very much for watching. Please like, subscribe and share.